Hi, everybody. My name is Jeff Morris, and I'm going to talk about benchmarks. This is going to be a fun presentation. I'm going to talk about Couchbase Cloud and recent benchmark tests that we have commissioned that took place over the summer, and I want to give you a preview of the results. These are unpublished as yet, but they will be published shortly, and let's get started. So let's talk about Couchbase Cloud for a second. Number one, the way we've presented it is as an expertly managed configuration and deployment of Couchbase itself. And of course, as you saw from the keynote and other presentations over the course of this conference, that Couchbase really has no equal in terms of its capabilities. We talk about superior performance, and we've proven that throughout the years with Couchbase Server itself. We talk about some new innovations like in VPC deployment with Couchbase Cloud. We often highlight the complete cluster control that you have afforded to you with the single control plane. Of course, it's globally deployable, and it supports exceptional TCO. And what we're going to do today is talk about that TCO argument and also highlight some of the other core capabilities of Couchbase Cloud. So my favorite one that we have been discussing throughout the course of the summer and prior to the launch of Couchbase Cloud in June is the notion of its ability to deploy inside your VPC, your virtual private cloud. And we feel like this is an emerging best practice, because what it really offers you is the control over your data that enterprises have had since computing began, when they ran their own data centers. They were always in control of their data resources, and that created a measure of security and a measure of confidence that you may be losing in today's software as a service world. But Couchbase Cloud is different, right? We deploy inside of your VPC. We give you the keys. We manage with a lowest permission available access to that VPC so that we can make sure the Couchbase Cloud is operating correctly. But then you are in complete control. And this is really highly beneficial for you. You get to choose the cluster instances that you deploy. And I'll talk a little bit more about that as we talk about TCO, where you get to pick what instances inside of AWS Couchbase Cloud runs. You get to pick the perfect instance to run your workload. Once you've tested it, you can figure that out. And then if you need to customize your deployment such as to support particular capabilities of the database, that's available to you. You don't necessarily have to rely on me to do it for you. You can do it yourself, or you can ask for our assistance, and of course, we'll help you. We accommodate all of this through a feature called multi-dimensional scaling. And what MDS does, it allows you to configure the major capabilities or major services of Couchbase on an individual basis on each particular node or instance upon which you're deploying Couchbase Cloud. So if you need a lot of indexing because you have a lot of queries that need lickety-split performance, that's fine. Allocate more resources to indexing. If you need, if you're performing analytic exercises and you need a lot of MPP processing of analytic data that's coming in through your Couchbase or your S3 environment, that's great. Tune it for that. So this multidimensional scaling capability allows us to really allocate or performance tune your database to the behavior of your application and to the characteristics of your infrastructure. It's really that perfect match that you are afforded here. Of course, we support elastic scaling. That's still a hallmark of Couchbase. My favorite feature is the ability for us to kill a node, rebalance a cluster, and then bring back the node and rebalance it again. When I say rebalance, all the data moves to its appropriate locations such that we can maintain a highly available environment, a fault-tolerant environment, even while accepting failures as they happen. And lastly, we support cross-data center replication for hybrid cloud kinds of deployments. That's where you have your in your particular cloud and an on-prem kind of deployment, or vice versa. So if you need to do backups to the cloud, we support that. If you need to allocate other clusters in the cloud from your existing instances, that's no problem either. So this workload shifting capability is really handy. An example of that is supporting data sovereignty kinds of requirements. So in EMEA, right, we have GDPR that we have to adhere to. So the data has to reside in the country of origin of the data owner. And you can make sure using XDCR that actually takes place. So some very, very advantageous capabilities here inside of Couchbase Cloud. So I'm kind of giving you the rundown of the product itself and the way that we've been describing it and bringing it to market. But what we're going to talk about today is some proof points of how Couchbase Cloud performs when it's measured up against its primary competitors. So we've commissioned a benchmarking exercise, a performance comparison test against Mongodb Atlas, against Amazon DynamoDB and Couchbase Cloud. We've chosen the Yahoo Cloud Serving Benchmark as our foundation for what we're going to test. So we've chosen 4 different workloads in that environment and at 3 different cluster sizes or 3 different scales. And what you're going to see is on a price per dollar or performance per dollar, Couchbase itself is unbeaten. And we're actually very excited about that. Of course, this whole report will be published within the next 30 days or so, and for everyone to not only evaluate, but if you needed to even repeat it, you could. And our core objectives there are to really understand the performance characteristics of our own product under a variety of load conditions, and understand and be able to articulate the operational costs of each one of these platforms in order to build a comparative TCO model. So I'm going to start to do that. I'll give you a couple of examples of how we are rating or comparing ourselves from a price performance kind of standpoint using this TCO model. So we picked the Yahoo Cloud Serving Benchmark sets of workloads as our foundation. So the first test that we'll talk about is a key value update heavy kind of workload where half of the activity that's going on is reads and half of the activity that's going on is updates to particular documents. The next one is that we'll talk about is a workload that scans short ranges. So it reads a lot, but then only updates a little bit of a few records at a time. The third test is a pagination workload, which creates an environment where we're looking across the entirety of the database and we're filtering our results with a particular offset and then limiting the results that come back from that particular query. And number 4, one of my favorites, of course, is a join workload, because Couchbase, as a document and key value-based database, supports joins. So if you're familiar with that from a SQL perspective or a relational database perspective, we support that directly as well. So these join operations, they have both grouping and aggregation capabilities, and really all they're doing is they're grabbing and assigning or associating customers with their particular orders. That's the configuration of that particular query. But it's looking across the entirety of the database, and that's the challenge. So when we set this stuff up, on the right-hand side here, this the YCSB client tool configuration, we're using 4 client nodes to generate work against each one of these cloud environments. And this work generation exercise, we're incrementing it by threads of 25 per client. So really when you evaluate the whole system, we're incrementing, because we have 4 of these client drivers that are going on against the database, and in the 25 workload environment, we're creating 100 threads worth of activity. And then we increase that up to 700 threads of activity. And there's some very interesting things that happen as we do that, not only with ourselves, but these other products as well. So as we look at the results themselves, and the configuration of the environment. Number one is the increments that we're using is we start with a 6-node cluster, and then we upgrade that by 50% to a 9-node cluster. All of the same machine type or very, very similar machine types. And then we increase that to an 18-node cluster. So you'll see that the 6 to the 9 is a 50% increase. The 9 to 18, of course, is a 100% increase. And at the same time, what we're doing underneath there with the records in the database and the data capacity we're dealing with is we have 50 million records to start with, and then we double it to 100 million records for the 9-node cluster. So note that difference, right? Only increase the capacity of the environment by half, but increase the workload or what it's containing by 100%. And then we just double down on it for the 18-node environment and give you 200 million records and increase that database capacity by 100%. So that's going to be an interesting variable that when we look at the results, what's been going on. So and then there's some core capabilities, the players, the environment, the costs of running each one of these environments. And there's some notable things here. So Couchbase Cloud, we're using in AWS the R5.2x large kinds of instances, 8 CPUs, 64 gigs of memory. I guess it's got about 200 gigs of storage, 10 gigabit bandwidth, all based in the Eastern region. Now, when I configure that and I buy it by Amazon and set it up, my monthly costs are listed here. So please take note of these, because as we go forward, we're going to end up talking about how does cost impact the performance criteria of all of these environments. Now, the next one is for Mongodb Atlas. And what we did is, because they operate as a software as a service where they provide both the infrastructure and the software for you, right? They determine or have made up their particular sets of instances. So there's an M60 instance, which is pretty comparable. It's got more storage, but pretty comparable to the kind of environment that Couchbase that I'm using in Couchbase. So it's 8 CPUs, 64 gigs of memory, lots of solid state storage right there, which is probably advantageous for them, and also based in AWS East region. Now, the interesting thing when we added in DynamoDB is that they don't actually expose the hardware that anything is running on or the node or instance types that anything is running on. You basically set your standard for how much read-write capacity that you want to enable. And hopefully you've created a ceiling that is high enough to support your workload. Otherwise, you can increase it, of course. That's one of the nice characteristics of this of DynamoDB. But because they don't offer that infrastructure-based selection, we had to figure out a way to match this into the same thing. So what we did was we took the cost foundation of the Mongo environment. So we said, all right, give me about $6,100 worth of read and write capacity. And then for the 9-node environment, give me about $8,950 worth of the read-write capacity, and about double that, maybe a little bit more for the 18-node environment. So we decided to match the Mongo environment for spend, because we want to give the broadest capacity available to DynamoDB in this regard. So I'm going to present to you arguably the best and arguably the most interesting, or one of the most interesting pictures or results of this particular exercise. And what we're looking at is workload A in the YCSB benchmark. And it's a read-heavy one. It's half the time you're updating documents and half the time you're accessing them. So when we look at the 6-node environment, we're fairly competitive down there. Certainly, Mongo's a little light, but by about a third. But between Couchbase and DynamoDB, we're pretty competitive, 10%, plus or minus 10% off kind of thing. But then when you increase the node availability for Couchbase, we take off, right? Handling write-intensive activities using our in-memory capabilities here, I think is really highlighting the benefit of Couchbase itself. So when you need to jack up performance for for an application that may be performing badly, right? Using Couchbase to present a high performance front end for that is probably a good idea here. And so on the 9-node environment, even though we just increased the environment itself, the infrastructure by 50%, doubled down the amount of data we're handling. So instead of writing 25,000 records, or 25 million records, we're writing to 50 million records. We're starting to really cook here, which is kind of nice. And then when you increase that to 18 nodes, it goes up again. Now, this isn't quite linear because, of course, that scaling step mark that I've called out earlier, but nonetheless, pretty impressive. And I think the other thing to call out here is the dotted lines represent the latency of each one of these activities. And you'll see that in terms of milliseconds, they're milliseconds. That's pretty good. But we're talking about 50 milliseconds for DynamoDB, and we're talking about 10 or 12 milliseconds for Mongo at its best, and then we're talking about barely 1 millisecond for Couchbase Cloud. So really, really high performance, super throughput here, nice setup. But now let's start to break this one down, because this looks like benchmarking, I'm sure. And while I'm going to give you probably a little bit more of that, I'm also going to reveal as much as I possibly can about how we're going about this and about how I'm attacking the logic of each one of these environments. So what I want to first introduce to you is sort of my cost of operations formula. And the formula has a number of metrics that I'm using and building upon to create the overall formula. And I'll just walk you through it. So the first one I'm taking note of is the monthly cost of operations. And this gives me a monthly cost of operation by vendor. And where I grabbed that was exactly what the testing organization spent on each one of these environments. So I know what was spent on Couchbase, and built out to a monthly basis. I know what was spent on Atlas. I know what was spent on DynamoDB. So that's kind of our cost baseline. And then the next one I want to bring up is the operations per environment per vendor. And that's what, when we were looking at this particular diagram, that's what in the 6-node configuration, the 33,460 for Couchbase, it's that value, that operations per second throughput that this particular benchmark was experiencing. And then we've got almost 20K for MongoDB and 30K or so for DynamoDB. So that's what is represented here in this operations per second per environment by each vendor. Well, here's the funny part. I have monthly costs and I have per second performance. So I have to figure out how to bridge that gap. So what I end up doing is I'm going to create a formula where if I was running everything at full tilt for each one of these things for a month, I would take the seconds per month and then and multiply it by that operations per second per environment. So my formula here, of course, is 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, and 30 days to a month. And that gives me roughly the calculation for the monthly cost, or how the monthly cost was determined based on an hourly basis. But it also gives me a way that I can level out and create a price performance metric that is actually legitimate in this particular case. So that metric that I care about right now, we're going to call it the millions of operations per dollar. So it's if I have millions of operations going on in a month and I'm spending money on it, what is that per dollar value that I'm gaining out of this particular exercise? So what that is it's the operations per second times the seconds per month times a million, or divided by a million, so I can make it a manageable number for the sake of a presentation, and then divide it by the monthly cost of that environment. So what I'm going to get are things like, do you support 3 million operations per dollar, right? Kind of metric. And then when I evaluate it, I'm going to look at that operations cost per dollar and figure out what's the delta between Couchbase and these other products. Because in some cases, maybe the other products do really well. But because the Couchbase environment costs so much less or to operate, maybe it balances itself out. I'll point that out when it happens. So when you look at an example of this comparison formula, what I've taken here is that first set of numbers from this particular test. I've taken the low end one, the most competitive one on the lower right hand side, 6 nodes and 50 million records. And so that's what I'm evaluating here. And then if I were running that for a month, it would cost about $4,200 for Couchbase, $6,100 for Mongodb Atlas, and the same because we performance matched the DynamoDB environment to MongoDB, about the same. And then so my operations per second on that particular test, 33K for Couchbase, as you saw, about 20K for Mongo, and about 30 for DynamoDB. And then our seconds per month is a universal constant. So what do I get as a result? I get these millions of operations per dollar. I get about 20.6 million operations per dollar from Couchbase. I get about 8.1 million operations per dollar from MongoDB Atlas. And I get about 12, almost 13 million from DynamoDB. So let's look, when I evaluate that and say, well, what's the advantage of Couchbase versus the other guys? So I'll call this the value advantage of Couchbase value advantage as a percent of that millions of operations per dollar. So we're looking at about 154%, right? 2.5 times better than what you see with MongoDB Atlas in this test. And that was, you saw that in the graphic. I'll go back to it. Right, we're about twice as high, which is great. And then we're about 60%, better than DynamoDB, which, kudos to both of us that we're performing admirably and comparably in this particular exercise. So that's kind of the foundation that I want to set up as we go through the rest of the presentation and talk about these 4 scenarios. So that was workload A that I just walked you through, and I walked you through the 6-node test, right? So that was one of 12 tests that we ran. But then when you want to start looking at the other tests and make some conclusions about them. So where you saw that we were 150, the Couchbase value advantage, that middle row, over each of our competitors here. So it was 154% when we were dealing with 6 nodes. So we're all pretty even, right? The workload and the environment are pretty well self-contained, and there's not any breakout, kind of obvious breakout performance environment that takes over. But then when you double down, or you increase the environment by 50%, and increase the database size by 100%, you start to see Couchbase pull away. So 515% advantage over MongoDB on the 9 nodes, and 267% advantage over DynamoDB on the 9 nodes. And then carry that forward, once we get up to a really big environment, the workload has increased pretty substantially. We're still maintaining more than a 400%, 4 times better, 4 times more performant than Mongo, and 3 times more performant than DynamoDB in this particular exercise. So their scaling is very consistent. Clearly, they take advantage of, as you increase threads, their performance works linearly. That's terrific. Whereas Couchbase jumps through the roof here. So the second test, workload E. This one is interesting in that it scans most of the database, or the activities are mostly scans of collections of records, or ranges of records. Collections is a loaded term. Ranges of records, and then we're updating, every 20th piece of activity. So here, in the millions of operations per dollar, what you see is, wow, Mongo did really well in the 6-node test. That's great. So Couchbase was at 7.6 million, Mongo almost 10, and Mongo about 7.1 million, and but when you roll in the cost advantage of the hardware environment, the infrastructure environment, remember the Couchbase environment is about 30% less in infrastructure costs than the Mongo environment. So you gain that benefit, and that's what ekes us out this 7% Couchbase value advantage over MongoDB. And then when we look at DynamoDB, still about twice as good as in terms of value advantage over DynamoDB. 9 nodes, Couchbase starts to take off again. Very likely in memory performance is what's getting leveraged here. And MongoDB flattens out at 4.7 million operations per dollar. And so we're about twice as good on that as at 100% improvement. And then when you start to look at DynamoDB, again, the issue with DynamoDB that our testers found was that when you set a financial ceiling for the capacity that you want to operate on your database, you're creating this artificial limit that the database itself doesn't really like. So as it's hitting that ceiling, when it's trying to perform up to snuff, it starts to throw errors when we hit when we hit that ceiling, and that's what's actually capping out DynamoDB here. Now, of course, if you want to throw money at the problem, go for it. DynamoDB will pick back up and scale as you would hope, and arguably perhaps scale infinitely. We haven't tested that particular situation. But under the 18-node workload, because Dynamo is hitting its cost ceiling, we come out way ahead of them. And Mongo looks terrific there. So their scanning capability across the database looks like it's very competent. But even so, we still, because of the cost of the infrastructure, come out, and the cost of the your core operating costs come out 43% better. So something to keep considering there. And actually, what's really interesting, the most interesting thing is where I said I was going to point out that where the other vendors were doing really well. Raw performance-wise, Mongo did great here in that 6-node test. But again, when you worked in the cost of that environment, your millions of operations per dollar, Couchbase comes out with a little advantage, 7%, nearly tied here. So I do want to recognize that there is that balance of if you're adopting Couchbase, you can do a whole lot more with a whole lot less infrastructure. So our next one is the pagination workload. And what this is doing is it's looking across the entire database, and then it's applying a filter and an offset, and then limiting the result set that comes back. And here, what you can see in terms of Couchbase operation and performance, pretty much across the board, even as we scale. And this is really dependent on the size of the database that we're looking at, right? Because it's looking at every record in the in the database. So on 6 nodes with a relatively small record count, Couchbase comes out at about 200%, twice as good as what you see with MongoDB. It's interesting to point out here that the next 2 examples that I'm going to give, this one and the following, DynamoDB threw so many errors when we tried to configure it normally that it wasn't able to do this full cross scan, paginated scan and filter, et cetera, because of its inability to search into the depths of the document without indexing, and it didn't have a way to index it. So that was kind of the disqualifier for DynamoDB here, is it wasn't even performing up to up to standard in any of the tests. So it boiled back down to being a Couchbase versus Mongo Atlas kind of evaluation. And as you can see, as we scale the thing, anywhere between 1.5 to twice as good or 3 times as good here is what you end up seeing. Of course, remember, 100% improvement is twice as good. 200% improvement is 3 times as good. So really, really excellent performance here. And finally, favorite one of ours is join performance. And this is a modestly, maybe it's an unfair fight. Dynamo, again, is disqualified. They don't have a joining capability in the environment. Mongo Atlas does have a join capability that they advertise with the $lookup function. The problem with the $lookup function is it doesn't work across shards. So that really constricts its particular behavior. So Couchbase doesn't have that particular problem. If you want to set up a bunch of documents, right, and then join them to another bunch of documents, and I'm being deliberate about calling them bunches, you can do that in Couchbase and join them against a particular common key, customer order, right, user ID number, something like that. So Couchbase can accomplish this. Not only in joining one thing to another, but joining many things to other many things. So, and here's where it really shines. On the 6 node, 10 times better, right? And on the 9 node, almost more than 15 times better. And then on the 18 node, when we start to give Mongo capacity where it can deal with everything, 4 times better. So, looking at all of these capabilities here. Right, joins are super important, and the reason why I was just describing everything as a bunch of documents is because there's a loaded term called collections, and collections are something that Mongo has had for quite some time, right? Pretty much since its inception. A collection of documents is almost like a table. Right, so you say you have documents, and they might be records of things. If you're mapping back in the relational world, so your documents collection turns it into a table, and you have a structure that organizations or developers are really familiar with. Now, Couchbase has had in our developer preview mode, right, which means we've had the feature implemented since version 6.5. Called collections, and also an adjunct feature called scopes. And collections are exactly the same thing as what we just described. You identify a structure, a collection or a group of documents, and determine them as being a collection, and you can almost treat it as a table. I mentioned this word scopes because the next structure up from how do you manage a bunch of tables. And in the relational world, the way you do that is through a schema, right? And so scopes themselves are almost like a logical schema of a series of collections, which are the equivalent of tables, and documents are the equivalent of records in the table or rows in the table. So we've created, and this is coming out in Couchbase 7.0, a structure that maps really nicely to a relational environment. So where we have a term we call buckets, which are kind of like the full database. And then we have scopes, which are like schema. And then we have collections like tables, and documents like records, and key values like cells. That's the way that we're going to end up helping organizations map what they're doing in the relational world into the NoSQL world. So I want to kind of stick that in as a explanation of both why joins are important and what's happening in the database itself as we look ahead. So here's a couple of kind of parting thoughts or additional considerations when you evaluate these performance characteristics. We will publish more documentation on this. The third-party Altoros is working on this particular write-up right now. They're trying to be as transparent as they possibly can be. So, but to consider other additional things when you're evaluating price performance and cost of operations. Couchbase itself, we offer variable instance rate pricing. So an R1 large has a different price point than a R2 extra large instance inside of AWS. So we vary it based on the performance characteristics that we see inside of that each particular instance. So for the calculation that we just used, the R5 2x large instance was priced at about 47 cents or so per hour. The next thing is to consider when you're looking at adopting one of these things, and especially when you're ready to deploy your application, is investigate reserved instances. Because reserved instances, both from your cloud service provider as well as providers from our, like ourselves, will offer you a much higher degree of discount for your longer term commitment, your annualized commitment to the environment. So AWS offers more than a 70% discount if you adopt a reserved instance or one of their other programs for as a long-term subscription kind of thing, because of course they want to be able to allocate the infrastructure for any given deployment. So you can save a bundle there. And then if you also decide to pair that up with an annualized prepaid contract with Couchbase, we'll give you an extra 20% discount on top of whatever you've negotiated as well. So for those prepaid credits. And the final point I want to make here is we also offer, based on where you are in the development process. If you're developing stuff, you're probably working a lot offline, you're probably working a little bit online, or a little bit in the cloud. And then when you start to test your environment, you move a lot more things into the cloud, but you're spinning up and elastically scaling and bringing back your environment. So you're using the elasticity of the cloud to test drive your deployment. There's a lot of there's a lot of benefit if you're doing that to take advantage of Couchbase's policy of relaxing the support burden that you require for your deployment. I say burden just because it's something that, of course, if you need a 24/7 support contract, of course we're going to provide it, but it's much more cost effective and much more lower support cost for you if you pick the 10x5 option, especially when you're testing your configuration in the middle of the day. Right, so you probably want to purchase that relaxed support contract, the Developer Pro level contract that we offer, because that gives you a 35% discount on your Couchbase Cloud expenses. Because as you can imagine, right, where's the cost center that we incur when we're deploying Couchbase Cloud, and it's it's in labor. It's much more than it's in the instance deployment, et cetera, that is our cost burden. So take advantage of the relaxed support levels to get a discount. Take advantage of reserved instances to get a discount, and take advantage of the fact that you can finely performance tune the instances that you do deploy based on what your application needs. You'll figure that out as you test it, of course. And then you can really maintain a high degree of control over your cloud expenses, because you're going to see exactly the itemization that you want. It's all available, of course, through the AWS Marketplace. You can do a private offer if you need to haggle a little bit with us. And we're more than happy to go through those exercises and come up with a situation where you find beneficial. Now, but what I really think I've also proven in this exercise is Couchbase Cloud really is legitimately the total cost of ownership leader in this regard. And so, kind of to close, I want to talk about a Couchbase Cloud customer of ours. This is a consulting organization called Facet Digital. And what they do is they go into organizations and they solve their tough problems. And they typically solve it in the cloud. And they typically solve it with NoSQL database systems. And when they realized, they were using a competitive solution in a different cloud than AWS, and were realizing that they just weren't getting the price performance that they wanted out of the environment, nor were they getting the functionality that they wanted out of the environment. And this was happening, geez, I don't know, right around, let's say, May of 2020, 6 weeks or so before Couchbase Cloud was going to be released. As soon as they heard about Couchbase Cloud operating, they knew they wanted the core features of Couchbase, right, that I've mentioned before, that performance, that in-memory capability, the indexing service, the query service, the data handling service. They wanted that flexibility and ability to tune everything, but they didn't have it in their other environment. So when Couchbase Cloud became available to them, they jumped on it. And so, their customers, they needed really high performance. They wanted super fast time to market. It used to take them, days or like a week to configure an environment to get a customer up and running. Now they can do it in 20 minutes. They found it difficult to achieve this cost-effective performance. Legacy databases were a problem. Time-intensive processes to set everything up. But when they switch over to Couchbase Cloud, look what happens. They cut their spend, their TCO by half, legitimately half, right? Take the IT budget, cut it in half, and give that back to the customer. And at the same time, they were able to increase their query performance in some cases by as much as 2,000%, right? 20 times better, 20 times faster. So 20 times faster at half the cost. That's a pretty good value proposition. So now they've optimized Couchbase Cloud so they can turn on a customer nearly immediately. 20 minutes is their kind of example versus the week, as I mentioned, but very, very successful deployment. And they are also featured here on Couchbase Connect Online. So last kind of consideration here, the core case for Couchbase Cloud. Not only is it Couchbase, number one, right? The most powerful, versatile NoSQL database that exists. You get key value, you get document flexibility, you get in-memory performance, you get eyes closed scalability, plus full text search, plus analytics, plus eventing. So it's got all of the things that most developers need. 10 different SDKs. Then you get the confidence of in-VPC deployment, which again, we feel like it's an emerging best practice here that allows you to control the data, the most important asset that you have by yourself. If you don't want Couchbase, you don't want Couchbase to access it, turn us off. So you control data, you control your security, you control your data sovereignty. You manage the entire environment through a single pane of glass. Multiple clusters deployed globally, whatever, it all comes back into the Couchbase control plane. We give you the hybrid cloud support of, for migration, for backups, for disaster recovery, or for just data center replication, right? Using cross data center replication. And number 5, which has been kind of the item that I've been chasing since we launched the product back in June, is this super customer positive licensing, proving out the best practice price performance and delivering demonstrably low total cost of ownership. And that's what the intent of this particular session has been, is I want to get to number 5, that core final proof point of we know it's going to be fast. We know it's going to be more cost effective than the other systems that you have a choice of. So take that flexibility that we offer, take the security we offer, take the cost control over back from your cloud provider or your SaaS provider. Your money's your own, and we know it's precious right now. So with all of that said, thank you very much. Please enjoy the conference and binge as much as you can. You'll gain a lot of benefit out of it. There's a lot of content here, but I really, really appreciate your attention for this session, and enjoy the rest of the event.